body water. Interstitial fluid and lymph. Interstitial fluid, that is fluid between cells in the bodies. That is in the body. That's interstitial, and lymph, 18%. Interstitial fluid is fluid immediately around cells. That's fluid around cells, just around the cells in the body. That's interstitial. Whereas lymph, everybody, lymph is fluid that has entered the lymphatic vessels. Has the same composition as tissue fluid. Interstitial fluid is also called tissue fluid. Same composition. In other words, tissue fluid or interstitial fluid, everybody, is fluid that's around cells in the body, around the cells. And lymph is same thing as tissue fluid, but it's inside lymph vessels. And so that's the lymph idea. And you kind of need to know what extracellular fluid is. See, in this class, somebody was asking me about a third degree, yeah, it was you, it was an Edgar, asking me about a third degree burn. Second difference in a second and a third degree burn as far as infection, as far as the severe. Well, a second degree burn, if you've ever had blisters from sunbathing or being out in the sun too long, you've had a second degree burn. Normally, and I've had those when I was doing phycology, being stupid in Galveston, collecting seaweed in this weather like we up until now, like we've been having, collecting algae out in the bay without a shirt on. That's so stupid. Oh man, I got totally burnt. Had blisters back here, had fever, hurt, but it got okay. It went well. Now, a third degree burn is burning through the dermis, the epidermis, dermis. What they worry about there is fluid loss and infection. So right here, in that part of that fluid, that's extracellular fluid loss and infection. And we talk about in microbiology, one of the main organisms that will infect a person is Pseudomonas aeruginosa. Pseudomonas, if you have a green scum on your body where there's been a bad burn, a greenish-looking scum-looking stuff, that would be like a Pseudomonas infection. It smells too. It smells bad, Shannon. Oh, Shannon. Smells really bad too. All right, now right here, everybody. Connective tissue fluid, fluid of dense connective tissue. Oh, what's dense connective tissue? All right, Case Keenum is undergoing surgery today on some dense connective tissue. What's he having surgery on today? ACL. His football career may be over. You know, it may be, depends on how well he rehabilitates. Although that quarterback at Baylor, Robert Griffin, is having a great year. He was medically redshirted last year because of an ACL injury, and he was very, very dedicated in rehabbing. And he's fast as he was. He looks good. I just hope he doesn't get hurt again. But this boy at the U of H depends on how well it goes. All right, so we talk about dense connective tissue, fluids of dense connective tissue. That'd be like a ligament, the ACL, anterior cruciate ligament. Okay, all right, and there's fluids in bones, transcellular fluids. These are, okay, that's fluids of the eye, fluid in the joint, cerebrospinal fluid, gastrointestinal tract, urinary, respiratory. That would be what's called transcellular. Makes up about 2.5%. Fluids separated from other extracellular fluids by an epithelial membrane. Fluids in the eye, the joints, the synovial membrane. Okay, the cerebrospinal fluid. You know, there's this membrane that keeps that stuff contained. All right, in the GI tract, there's fluid associated with that. Urinary, respiratory. Note, body fluids, now this is just kind of fluid, I won't ask you this, but look at this. Body fluids form an internal environment for the cells. pH, osmotic pressure, temperature, and other characteristics must be maintained within narrow limits. And that's just telling you this. Body fluids form an internal environment for the cells. The body fluids do. And in other words, pH. Now one thing that you can think about this. In chronic obstructive pulmonary disease, COPD. All right, in COPD, chronic obstructive pulmonary disease, one of the key things that brings that on is, cigarette smoking. COPD, characterized by chronic bronchitis and emphysema. And in COPD, a person can take air in, but they can't get it out. It doesn't all go out. And so the CO2 is converted to carbonic acid. The carbonic acid, which we'll learn in respiration, carbonic acid in the cells is ionized into H+, and HCO3, the H+, will have a drastic effect on the pH of the blood. And the pH of the blood must be about 7.35, and that not being able to get rid of this carbon dioxide will translate, which you'll see later, will translate into an elevation of hydrogen ions.